Time to revise a bit of concepts from your 11th standard before you start your journey of 12th standard. Be it JEE, be it NEET, both of you are welcome. Hello Ninja, hi Natarajan, Sneha, Madhusudan, welcome aboard to the revision and backlog covering series and your Kickstarter series for your 12th standard. These are certain things which you should do when you step your foot in the 12th standard. Now, I know some of you have already started your journey, and if you have started your journey, raise your hand, and you would have noticed that there are times when you are studying electrostatics or Gauss law or even maybe magnetism, you would have noticed, oh my god, I don't remember the formula. Oh, I've suddenly forgotten, the scalar product or cross product rules. Oh, I suddenly don't remember how to, add vectors. I know it, but maybe I'm not so comfortable. And it happens because you're not in touch with those topics, because it has happened almost a year back. So I have got this series for you, and I'll be also, like I said before, I'll be doing problem solving, one shots and quick concept problems and all those things for your 11th to 12th moving students for the entire 12th standard syllabus. And all of this is going to happen with your favorite captain. And my name is Shreyas. I'm the physics master teacher on the channel and also at Vedantu and training kids for a very long time, just like you, as always. So yes, application of integration is trouble. So I'm going to give you certain tips and tricks, not just for kinematics, but for in general, any kind of application of calculus. We are going to do it today. And let me tell you, I'm going to do problems on the spot as well. And no limitation on, as such that we have to do only those questions which are there on the screen. Okay, exactly. Mohan is saying exactly is in the same mood. Snehal Patel is also agreeing with it. Nakshatra also agreeing with it. I'm so glad you guys are with me on this. Hi Khima, hi Surinder. And let's begin with the class. And if you want to know more about me, you know where to go on Instagram, and that's my Instagram handle. And yes, if you're new to the channel, please hit the subscribe button, because that's when you get all the important updates, notifications, and all the classes which I'm going to conduct for the 12th grade. And I want you to come here in full spirits and watch these classes along with your pro classes at Vedantu, or even if you're in some other institute. Remember, if you're watching all my classes, yes, I'm teaching the 12th standard batch for Vedantu's, the English medium students. Make sure that you also sync up with the current syllabus which I'm teaching all the students on YouTube. This combo is going to be awesome, and this is going to be a deadly combo to get very good marks, I can assure you, in your upcoming JEE and NEET exams. And if you're already a subscriber, you know what to do. Go ahead, smash the like button, and do not forget to join the Telegram channel where you get all the important updates, PDFs, homework solutions, everything. So make sure you do that. So let's begin with the vectors. Hi Samyukta, hi Varun. A lot of students are new, like I can see, and so glad that many newcomers are also over here. Okay, so well, Ruko, that's wrong. You you need basic maths. Yes, definitely you need basic maths. And I'll tell you, Ruko Jara Sabar Karo. Oh my god. Okay, sorry. I was thinking it's a name, and then I realized, oh my god, it's a Hindi phrase. Ruko Zara Sabar Karo. Okay, cool. So I have made some awesome lectures in the Nurture playlist. After this lecture, if you feel like watching in detail classes, make sure you check out the playlist which is there right over here. I'll just show it to you. It's there right over here, guys. Just go there and you will see the 11th standard classes. The complete 11th standard class is there right over here. You can see that. View full playlist, Nurture Physics playlist, 11th Physics. So click on this and you'll get everything, including units and dimensions, vectors, everything. 1D. In 1D only I have taught you integration and derivatives graphically, analytically, everything application wise. So make sure you watch it in case you feel that you want more content on today's talk. Definitely. Yes, Ninja. So what and all I am planning to do in today's class, I'm going to revise vectors, of course, and then in basic maths, I want to revise derivatives and integration. I don't want to do trigonometry and logarithms because that's something which you will do in maths eventually. But I know the application of calculus is something which most often students need. All right? Yeah. So yes, Devanandan, well, the Lakshya batch, we don't have something called as Lakshya batch. We have the Drishti batch and the Sankal batch and the Manthan batch. All right. So let's begin, guys. I hope you guys are on full josh. So let's start with the revision of vectors. Now, basic things that you need to know about vector notations. Let's start with that first. All right. So we know that anytime you have to represent a vector quantity. What is a vector? Vector is something which has magnitude as well as directional information both present in it, and the second important criteria, it should follow the rules of the vector addition. So many things are there which have magnitude and direction, but still they are not vectors because they do not follow the rules of vector addition. Can you guys name one such quantity? Can you name one such quantity? Definitely, Obila Ghosh. I am planning a session on gravitation very soon. Welcome aboard, everyone. So what is that one quantity which you can think at the back of your mind, which has magnitude, which has direction, but still it is not a vector quantity, guys? Yeah, that is, yes, Gitendra, personal mentorship is also available, bacha. So that is basically current. Yes, very good example. Even time is an example. Time also flows in forward direction, but it does not follow the rules of vector addition. Even current cannot be added via vector addition. It just adds 1 ampere plus 2 ampere is 3 ampere. So it's not a vector quantity. Now, whenever you have to represent a vector, let's say example, displacement of Pandu. So Pandu has gone, he has traveled, for example, 20 kilometers, he has gone 20 kilometers to meet his girlfriend Champa in the northeast direction. So vector wise, I have multiple ways of notating it. Symbolically or mathematically, I can write displacement of Pandu is, I can write 20 kilometers in northeast direction. Graphically, I can just show a line, arrow mark. This is your tail, okay, and this is your head, and I can show a legend over here. This is north and this is east. This, I can say that 1 centimeter is 1 kilometer. So I can draw an arrow mark of 20 centimeters. So the length of the arrow mark corresponds to the magnitude. So if I just put S bar modulus, then it is just the magnitude of that. So it will be just 20 kilometers. And another way of writing it is, since it is 20 kilometers in the northeast direction, I can say something I cap, something j cap. Something in I, something in j. Do you remember this I cap, j cap notation? So usually you don't write like this, nor do you write, unless and until you have some graphical problem, you don't show it like this. You usually write it in I, j, k notations. So you split 20 kilometers into two components, two parts, something in x, something in y. So if this is 45 degrees, this will be nothing but 20 cos 45, which is 20 by root 2. This will be also 20 sin 45, which is also 20 by root 2. So this will be nothing but 20 by root 2 I cap plus 20 by root 2 j cap kilometers. So what is this ijk? I'll come in a bit, but this is also a very good way of representing the vector quantities. This cos sign also I'll be elaborating in case you have forgotten and you always get confused which is cos, which is sine. Don't worry about it. So this is all about vector notation. Also remember, you have something called as the unit vector. So a unit vector always has a hat over it. So if I say a hat, it means it has a magnitude of 1. B hat magnitude 1, C hat magnitude 1, I hat magnitude 1, J hat magnitude 1, K hat magnitude 1. And if I tell you this is a vector A, but it is not of 1 unit length, it's some maybe 10 meters or 20 meters or 100 meters. A vector, unit vector, in that particular direction, in the same direction, but of unit length, A hat will be, this A hat will be A vector divided by the magnitude of that. A vector divided by the magnitude of that. That is the formula. Yep. So keep this in mind. Hello Vandana. Very good Mohan. Very good Ninja. Yes. So force, somebody said force Varun Krishna. That's wrong. Force follows the rules of vector addition. It is a vector quantity. Okay. So please don't get it wrong. So these unit vectors are very special. They have a lot of importance. The three major unit vectors which you need to know is I cap, j cap and k cap. These are special unit vectors in the direction of x-axis, y-axis and z-axis, all of them being positive. If I say minus I cap, it is along negative x, minus j cap is minus y-axis, minus k cap is minus z-axis. Keep this in mind. Okay, these are special unit vectors. Now, let's say if I tell you, is I cap, this is just an example, is I cap plus j cap plus k cap or rather an unit vector? Is it an unit vector? What is your answer, guys? Is that an unit vector? Is that a unit vector? Yes? No? Think about it. I cap plus j cap plus k cap. Do you think that as a whole is it a unit vector? I feel that it is not a unit vector. And why is it not a unit vector? Think about it. You should always check the magnitude of that. So the moment you check the magnitude of I cap plus j cap plus k cap. Now how do you check the magnitude? How do you check the magnitude? Remember, the coefficients squares should be added and put it under the root. The coefficient, I cap's coefficient is 1, okay, j cap's coefficient is 1, k cap's coefficient is 1, square them, add them and put it under the root. So it will be basically root 3, which is definitely not 1, hence it is not unit vector. It is definitely not a unit vector. So this leads us to the magnitude of any vector. So the magnitude of any vector, okay, any vector is given by v bar, which is equal to, let's say, vx I cap plus vy j cap plus vz k cap. That magnitude is given by root of vx square plus vy square plus vz square. What is vx, vy, vz? Vx, vy, vz, these are the components of the vector. So what is vx, vy, vz? So vx, vy, vz, these are basically the components of the vector v bar. So this is your magnitude of that vector. Very good. Excellent. Hello Hari, we enthuse. All right. Hello Ankit, all the best for your Chem exam too. And guys, I'll be doing a marathon series for all the 10th as well as the 12th standard students. So if you're a 10th standard student writing 10th board exam on this channel in English medium, for your physics, I'm going to do a series. And if you're a 12th standard student, a marathon session and all important sessions before your physics board exams. All right. Now, when I say resolving, keep this in mind. Okay. Yes, Ninja, I will come to that if you want in a bit. Area seems to be scalar, but it is a vector. We treat it like a vector for convenience sake, and it helps us calculate many other quantities like flux you will see in electrostatics and magnetism. All right, I'll just come to it in a bit. Just give me some time. Now, if you notice over here, this is basically, resolution of vectors. Resolving means split into components. Split into components. Like you get scoldings from your mom and dad. I will break you into pieces if you don't study. So that is resolving. So, but you are not a vector. Okay, you are a human body. So resolving means splitting into components, splitting into small parts. Any vector can be thought of to be made up of 2 or 3 or more components. But there is no use splitting a vector into random parts, random pieces. You always try to split it into 2 or 3 components, which becomes useful for solving the problem. If it is in a 2D plane, you split it into 2 components. If it is in a 3D plane, I will show on the next slide, you split it into 3 components. Hi Saja, welcome aboard. Okay, this is for 2023. Draw and draw. This is a session for 2023 students in case you have missed it. All right. So this is exactly for you guys. Make sure you are attending it. All right. So going ahead. Yep. So remember, whenever you see a vector and there are 2 axes, so you're splitting it into 2 components. This is your x component, this is your y component, Lot of people by heart, x component is cos theta, y component is sin theta. That is wrong. That is not how it is. If theta is close to the x component, look at this. This is the main vector. Theta is close to the x component. So in Hindi, close means, in Hindi, close is nothing but pass. Okay. Now, if you do not know Hindi, it's okay, guys. But just remember this, pass. Tum pass mein ho, tum mere paas aa jao. So, guys, in Hindi, it means close. So, pass is very similar in rhyming with cos. Cos, pass, rhymes together, right? Hence, Madhusudan, it's not about fancy names, bacha, it's about the content. So the content is very important, okay? So right now I'm just calling it, you need to do these things before 12th. So that's the name of the series, what you need to do before 12th, okay? And that's why the close component, the closer component is cos component. Far, you are going very far, you are committing a sin. So when you go far away, you commit a sin, or basically sine component. So it's far away, so that's sine. I'll give you one more example so that you will never forget, guys. Come on, let's do this. So let's say this is my vector v, and let's say this is angle theta. So I'm going to split it up into two components. Everybody with me? Everybody with me? All right, let's see this now. So look at this vector, components, two components, one in x, one in y. Can you see the two components, bachalo? Can you see these two components, warriors? This is a vector. I'm splitting it into two components. Yes, because it is in the third quadrant, I'm going to split it here and here. Now, the one which is close means cos, pass. So this will be v cos theta. This component is far away from theta. Far means you have committed a sin. So that means it is v sin theta. That's how you're going to remember. Very good, Kalyani. Vertical is cos. Horizontal in this case is sine component. Perfecto, excelente, amazingo. Moving on to the next concept of 3D resolution. See guys, I'll tell you one simple thing. Whenever you have 3D, right, I always tell my students, try to imagine it as if it's a room, and inside that room, the vector is one of the diagonals. So this is like a room in which probably you are sitting. Hopefully your room is cuboid. Alright, and imagine that vector in 3D always to be from one diagonal or from one vertex to the other vertex, oppositely faced. Basically, it's the diagonal. So let's say, for example, I tell you, I'll just draw some vector. Maybe let's say like this, or say. So see this is a vector. Imagine this in 3D. This is your length, breadth, and height of the room. It has three components now. Notice, one is your x component here. This is your x component. This is your main vector. This is your x component. Then you have your y component. So it is vy. And then finally, you have your z component over here. This is one way of looking at this vector. So imagine that corner which is behind you to another corner which is in front and on the top of you on the right hand side. So that is the vector. It has x, y, and z components. All right. Similarly, I can show you another one. Look at this. I'll show you another one right over here. So let's say a vector like this. Look at this, a vector like this. Now you are able to visualize, I'm pretty sure. Look at this. This is vector v. It's coming from a corner behind you on the top, on your left, and going down like this. How to visualize? Just split it up, guys. I mean, like, just go like this first, and then maybe you can go like this, and then you can go like this. So this is your z component, this is your y component, and this is your basically x component. So vz plus vy plus vx. So you can think of basically three vectors like this. One is vz, the black one which I'm holding right now is vz. I hope you can see it. Or maybe I will use some different color, maybe red color. So red color is the one which is vz coming towards you. Vy is going down, so the blue pen is going down like this. So that is one vector. And another vector is vx, the black one which I'm holding right now. So these are your three components. I hope you can visualize this, okay? Just visualize this. So basically the one which is joining from here to here, the tip of the black pen, that is your vector. Are you able to visualize this now? Just hold 3 pens, then you can see it. Yes, no, it's more than that, Tejasri. It is going to be around 1.5 hours at least. Okay, so these are the components. So this becomes very easy to visualize when you visualize it in terms of a cuboid and a diagonal. Connect the vertices on the opposite sides. Becomes very simple. Where will be the resultant vector in 3D? Mohan, this vector itself is the resultant. If you notice, V vector is Vx vector plus Vy vector plus Vz vector, which is Vx magnitude wise I cap plus Vy magnitude wise j cap plus Vz magnitude wise k cap. So the magnitude of the entire vector is Vx square plus Vy square plus Vz square, because you know that the diagonal length of a cuboid is the length square plus breadth square plus height square's root. So that's how you get it from. Understood, guys? Perfect, Mohan. Is that clear, bachalo? Okay. One last thing before we go ahead. I think I should have put it maybe before only, but it's fine, I guess. Maybe I can put it somewhere here. All right. So remember one thing, guys. Whenever you have vectors, let's say V1 and let's say V2, if they ask you what is the angle between the vectors, always ensure that their tails coincide, and then only measure the angle. Only when the tails or the heads, doesn't matter. See, imagine these are two vectors. The angle between them is the one between them. That is the angle. But when head and tail coincide, then it is not the angle. If you want their heads to coincide, then make sure you slide both of them and then measure this angle in between. All right, I hope this is clear. Yes. So, yes, Vignesh, both teachers are teaching. Obviously, all our teachers will teach, bacha. All our teachers will teach. Okay, so let's solve some questions coming up on your screen. I want all the students' answers. I want complete spam in the chat box right away. Yes, Jesse Rajumunan, this is exactly for all the students who have moved from 11th to 12th. You are right now studying in 12th basically, or maybe you are just about to complete your exams. Either of the two, this is exactly a session for both the kind of students and also for JEE and NEET. Remember that. Please cover your backlogs using this session, and even if you don't have backlogs, revise the concepts. I know many of you know these topics, but revise the concepts before you start full-fledged preparation of your 12th, or maybe you're not able to solve the problems, most likely because you have forgotten the concepts. D, are you sure? I doubt, guys. The vector which coincides with initial and terminal points. Oops, where did it go? Oh, it's zero vector. It's there, right over here. Guys, I'm not sure why you said D. It is not D. A vector which coincides with initial and terminal points. The initial, this is initial, this is the terminal. If both these points are basically same, that means this point and this point are the same. That means the magnitude of such a vector is 0. The length of such a vector is 0. Hence, it will be a zero vector, or you can also call it as a null vector. What is the meaning of a free vector? A vector which can be slided freely in space without having to worry about its consequences is called as a free vector. Okay, so let's say for example your velocity. Usually you can move the velocity, you can slide the velocity as per your wish. You can take this velocity vector here and you can make it go like this, or you can take it here and you can slide it over here. You can take it here also, you can make it slide here. So it's a free vector. But sometimes you will see a force vector cannot be slided as freely as you want, because you would have seen the formula of something called as the torque. Torque was nothing but R cross F. R is the distance from the axis to the force. So if you are measuring the torque here and if the force is here, then this is your R, But if you slide the force even somewhere else, maybe parallel only, then remember the R will be different. So if you slide the force, then you will get a completely different value of the torque Alright, so you cannot slide it freely. Is that clear, bacha? So many of you had that doubt. Okay, when can I slide a vector, when can I not? In certain cases you can, in certain cases you cannot. Obviously, those things which depend on axis, those things which depend on the orientation and all of that, or the point of choice about which you are measuring it, like angular momentum, torque, all those things you will see, you cannot slide the vector freely. Okay, in those things you cannot slide the vector freely. Equal vector we know, equal vector means the two vectors are equal in direction and magnitude. Same magnitude and same obviously direction. Moving on to the next points. Alright, what do we have over here? A force is inclined at an angle of 60 degrees to the horizontal. If the rectangular component in the horizontal direction is 50 Newton, then what is the magnitude of the force? Come on, my warriors. Very good, Kalyani, very good, Saja, very good, Sundar. And what is vector? Oh, Doraemon, don't worry, bacha. I'm pretty sure by the next attempt at least you will know what a vector and what is few more things. So watch my lectures regularly. You will not be in the same state. Okay, Doraemon, Pokemon. Let's see what's the question over here. We have a force which is inclined at an angle of 60 degrees to the horizontal. Okay, so we have a force which is inclined at 60 degrees to the horizontal, and it is given the rectangular component in the horizontal direction. What do you mean by rectangular component? So when you split a vector into two perpendicular components, they are called as rectangular components. It looks like a rectangle. You can complete the rectangle right over here, 90 degrees. So rectangular components, this is your x component, this is your y component. Fx will be, this is closer, cos, pass, cos. This is sine. So fx will be f cos theta or f cos 60. Fx value is given to be 50. So 50 is equal to f cos 60 is nothing but half. So f is nothing but 100. So hence the correct option should be option D, which is 100 Newton. Very good, Olivia Ghosh. Amazing. Let's move on to another question coming up on your screen, guys. A vector with magnitude A, then the unit vector A hat in the direction of vector A is, come on guys, you should know this. This is magnitude into vector. This is A dot A, this is A cross A, this is vector divided by the magnitude. Yep. Yes, Ranjit Kumar, it is 100, bacha. Very simple. I want you to revise all the concepts today. Come on, let's see if you can do this. Okay. Well. All right. So, the correct answer, yep, D, of course. Excellent. Proud of you, my warriors. Next question, D. Obviously, this is vector divided by the magnitude. I just told you, right? A vector is the vector itself divided by the magnitude of it. So it's exactly that. Exactly that. All right. Next question. Find the value of x if the vector here is something I cap plus something j cap minus something k cap is a unit vector. If this is a unit vector, then what do you think is the what do you think is the value of x in this question? Come on. And after this, I'm going to do an amazing mind-blowing problem for you that will probably give you a lot of interest and will blow your minds also. All right. So let's see if you can do this question. Find the value of x if this is xi cap plus 0.5 j cap minus 0.2 k cap, and that is itself a unit vector. So remember, if something is a unit vector, what does it mean? The magnitude is 1. So what's the magnitude of any vector? The magnitude of any vector is x square component plus the y square component, which is 0.5 square plus 0.2 square. The minus sign really doesn't matter. The whole thing under the root is basically 1. Take squares on both sides, it will simplify the equation. X square, 0.5 square is 0.25, 0.2 square is 0.04 is equal to 1 square, which is 1. So x square will be 1 minus 0.25 minus 0.04, which is 0.71. So x will be root of 0.71. How many of you got it? Very good, Oblia, very good, Natarajan. Very good, excellent. Option D is correcto. Amazingo, proud of you. Amazing, you're doing great. So now let's go to some another awesome super duper question, and for that let me just make use of my blackboard, just like in your regular schools or how it was long time back. All right, so let us imagine, okay, let us imagine a question something like this. A vector of magnitude 10 makes, all right, let's say 60 degrees with xz plane, and the shadow of the vector on xz plane makes 45 degrees with plus x axis. Interesting. 45 degrees with the plus x axis and the plus z axis as well. Okay, so this is the part of the question. Now the actual question, what do you have to find? Find the components. Find the components and write it in vector notation. Write it in vector notation, IJK. Okay, that's the question. Let's try to do this question. Everybody with me? All my warriors with me on this? Excellent. Let's do this question now. First of all, what did I tell you? Whenever you see a vector in 3D, try to imagine a cuboid. Probably that will solve many of your problems. Especially this kind of problem is going to definitely require some kind of visualization. So probably let's start with some visualizations, and let me just draw a cuboid. Now I know I have this convenience of drawing a cuboid right over here. Okay, so let me just show a cuboid. Wow, beautiful, isn't it? Amazing. So let me also show the vector itself, and let's say this is the vector starting from here to here. This is our vector. Okay, so let's start writing everything. So a vector of magnitude 10. So this yellow line has a magnitude of 10. All right, so this yellow line has a magnitude of 10 units. Now also let me show the axis, of course. So this is your x-axis, this is your y-axis, this is your z-axis. Everybody with me? Everybody with me on this? All right. So the vector of magnitude 10 makes 60 degrees with the xz plane. xz plane. See, the vector is like this. Visualize a vector like that. This is your, or basically this is your x-axis, this is your y-axis, and this is your z-axis. Visualize a vector like this. Think it makes 60 degrees with this ground plane, horizontal plane. That means this angle is 60 degrees. If I show a dotted line probably like this, it makes more sense. Visualize this. Are you able to visualize this now? 60 degrees with the horizontal plane. And that, the shadow of the vector. Shadow means if you place a stick, how will the shadow form? Shadow will be formed on the horizontal plane. Have you seen a stick's shadow? Have you seen your shadow? The shadow falls on the ground. So imagine the rays of the sun coming from the top. The shadow will be formed on the ground, on the horizontal plane. Do you notice that technically speaking, this is nothing but the shadow of that vector on the xz plane? And that shadow makes 45 degrees with x, 45 degrees with z. So this and this both are 45 degrees. Both are 45 degrees. Now I think I can solve the problem very easily. I'll tell you how. Do you see a beautiful right-angled triangle over here? Do you see a beautiful right-angled triangle in 3D where the 10 is the hypotenuse? So 10 is basically your hypotenuse in the right-angled triangle, and the shadow is the base. The shadow is basically the base, and the included angle is 60. So we know how to solve this problem ahead. So basically the length of that shadow It's closer to 60. Cos, pass, close. So cos 60. So shadow will be the 10 cos 60 component. Everybody with me on this? Yep. Thank you, Mr. Innovative. So this is for both JEE and NEET Innovative. This is for both. All right. This is for both the kind of students. Yes. And what is cos 60? It is 5. So this will be nothing but 5 units. Everybody with me on this? Perfect. Now I want your focus completely over here. This line will give you the y component. This line will give the y component. It is far away. It is far away. So the vector's y component will be 10. This will be 10 far away. Far means you committed a sin. So sine. So 10 sine 60. So this will be 10 root 3 by 2, which is 5 root 3. Everybody with me on this? So the y component is 5 root 3. Now the shadow is 5 units. But I don't want the shadow. I want the x and y components. I know what to do now. I can clearly see a right angle triangle over here on the base as well, if you want to look at it that way. Look at this. On the base, I hope you can see that there is a beautiful right angle triangle. It's flat. It's horizontal. I hope you can see that. Where in that horizontal right angled triangle, the shadow is the hypotenuse. The shadow is the hypotenuse. Observe that carefully. And then I can say this is the x component and this is the y component. This is x and this is y. But coincidentally, the good thing is the x and the y will be same because the shadow makes 45 with x and with y. So hence both x and y component will be same. Everybody agrees with this? Okay, what if I take the angle as 60, 45 degree and then doing 10 cos 15? No, Ubisha, you have visualized the problem wrong then. That's why visualization is important. Number one. Number two, always start with a cuboid. And number three, you should realize which is horizontal, which is vertical, and where will the shadow fall. So always when you visualize a stick at an angle, then you will realize, oh, the shadow will fall on the ground, which is the XZ plane. Then you will not go wrong and you will not make that mistake. Okay, so now that you have understood that, so what will be the value of Vx and what will be the value of Vy? It will be nothing but the shadows cos 45 or sin 45, both are the same thing. Shadow into cos 45. Shadow's length is nothing but 5. Cos 45 is 1 by root 2. So I've got the value of Vx and Vy. Hence my final answer will be beautiful color. So V bar will be equal to, what is the x component? It is 5 by root 2 I cap. What is the y component? That is also 5 by root 2 j cap. And what is the z Vx, and this was Vz. I'm so sorry guys. This was supposed to be Vz. So sorry. This was supposed to be Vz. So I think I should change it. Oops. Can I go undo? Yes, I think so. Yeah. So how do I erase this? Oh my god, I don't know how to erase this. Do I have an eraser? Maybe not. All right. So, okay. So not this. So sorry guys. So Vx was nothing but this one over here, Vx and Vz. All right. Vx was 5 by root 2. Vy was 5 root 3 j cap, and the z component was also 5 by root 2 k cap. Okay, so this was x and z. So I had to put z over here. Okay, so I think that was the small error while writing down. Okay, I hope this is clear, my warriors. So the x and the z components were equal. X and z components are equal. The y component, I found it out from here. So this is how you can solve questions of 3D. You will need to visualize such things at times. You should know how to split the components in 3 dimension. Okay, such kind of information can come in different ways in magnetism and electrostatics. Even if it does not come directly, you will need that concept of 3D vectors. Keep this in mind. Okay. Oh yes, this is the eraser. Thank you. Yes, yes, you're right. Yep, that's the eraser. Thank you. Oh yeah, I'm not used to this board. I'm used to the previous board. So sometimes it happens. Thank you. Okay. Yeah. See, kids are smart. Sitting there only, you guys realize which is the eraser, which is the pen. Very good, guys. Proud of you. Okay. So let us go back and yep. Let us go back to our session. Exit note. Save, please. Okay. Save it in this file so that I can probably share this with you later on. Shivan sir is traveling, Ninja. So he will not be there for this entire week. Okay. Moving on to the addition and subtraction part. So whenever you have two or more vectors and you want to add them, what you do is basically have to use the triangle or the parallelogram law. So let's say I have two vectors. I'll just show it to you. You already know, have seen it. You want to add this force plus this force. First way, take the vectors such that the tail of one, this is the tail, falls on the head of the other. The tail of the blue falls on the head of the red. Now there is a missing side. This missing side is your resultant vector. This vector plus this vector is this missing side. Is that clear? This is one way. Yes, I'm going to show you applications of calculus also. Next thing, another way, this is triangle, second is parallelogram. You have another option, you can join both their tails, you can complete a parallelogram. From the same point, draw the diagonal, that becomes your resultant. Both ways are fine. That is basically your vector addition. So you can see right over here, that's the same thing. It's shown this is triangle law of vector addition. This vector plus this vector is this vector. So you have both the laws, the triangle law and the parallelogram law. Which one will you use? You can use anything, anytime. It's your choice, your convenience. But you should be comfortable with both. Keep this in mind. Also, when I say addition of vectors, a bar plus b bar will be b bar plus a bar. This law is basically called as the commutative law. So the order of the addition really does not matter. And when you have more than two vectors, you can use the polygon law. So for two or more vectors, you can use the polygon law. So in polygon law, what is it? You take one vector, then you put another vector, then you put another vector, then you put another vector. Just keep on continuing it till you land up at the final vector. So there will be a missing side. There will be a missing side of that polygon. This is your missing side. This is basically your resultant vector. This is your resultant vector. And if by chance all the vectors that you have drawn somehow end up completing the polygon, the final vector lands here, then the net vector sum will be 0. Keep this in mind. Yes, vector is also there in maths. Yep. Yes. So yeah, remember that in triangle law, it is always head, tail. In parallelogram law, it is tail. All the tails coincide together. If you notice, the tail. So the resultant vector's tail will be coinciding with the two vectors. This is tail. In case of triangle, it is head, tail, because you show one vector like this, show another vector like this, another vector, the resultant comes over here. Head, tail. Clear, guys? All right. I'm so glad, Sanya, and will be supporting you for all the exams, bacha. All right. Now the formulas for vector addition, you should know it. So if the resultant vector is a vector plus b vector, it does not mean, it's not necessary that r is equal to a plus b. That is not necessary. Keep this in mind. Their magnitudes will not add. In fact, the magnitude will be a square plus b square plus 2ab cos of theta. What is theta? The angle between the two vectors. So the angle between the two vectors is measured here. A lot of you might be thinking, why did sir not mark this angle? Although a and b are here, I could have taken this angle. Reason is, when the vectors head and tail coincide, you should not measure the angle. Slide this vector and then measure the angle. That will be angle theta, and that same angle theta is over here. Keep this in mind. Remember, the tails should match, only then you can measure the angle. Okay, now moving on. When will this have maximum value? What will be the maximum value? The max value will be a plus b, and that will happen when the angle between the two vectors, basically theta is 0 degrees, basically they are parallel. That's when it is maximum. And the same minimum value will be nothing but modulus of a minus b, whichever is bigger first, and that will happen when theta is 180 degrees, basically they are opposite. That means they are anti-parallel. Keep this in mind. Everybody? Yes, Mr. M, definitely. Then, if you remember this much formula, that is very, very important. That's more than sufficient. Moving on to the next point, subtraction of a vector. So when I say subtraction, it is actually addition only. So when I say subtraction of a vector minus b vector, it is actually a vector plus negative of b vector. So you take the negative vector, like over here, this is f2 vector. So you want to subtract it. So basically you take the negative of that, that is it. And then you add these two vectors. That will give you the resultant subtracted vector. Whenever you see subtraction, you are generally talking about the change in the vector quantity. So all those places where you are talking about change in momentum, or change in force, or change in any such vector quantity like velocity, all those places you need to use vector subtraction. So I'll just give you an example for this as well in a bit, but before that, the formula. The subtracted vector's magnitude will be a square plus b square minus 2ab cos theta. So minus sign comes when you are using subtraction formula. That is very, very important. Is that clear? Yep, yes, Mr. M, you can definitely write running roads if you want, but if you feel that you're not able to cope up, then you can write it even later on, because the lecture will be available to you. My favorite emoji is the heart emoji, the heart one, the red one. All right. So let's go to some problems, but before that, just an example. Imagine Pandu is traveling towards east with a velocity of maybe, I don't know, 30 kilometers per hour. Then he suddenly turns towards the north direction and he has a speed of 40 kilometers per hour. If I ask you in this question two things. First is, what is the change in speed? Then what will your answer be? Come on, my warriors. Let's see how many of you can give this. Change in speed. Change means subtraction. So change in speed means final speed minus initial speed. Final speed 40, initial speed 30. So it is basically 10 kilometers per hour. Now remember, speed is a scalar quantity, so you don't have to worry about the directions at all. But if the question says by chance, if it says change in velocity, then keep this in mind, velocity is a vector quantity and you will have to then do final vector minus initial vector, which is final vector plus negative of initial vector. So initial vector is this way, negative of that vector will be this way. So the negative vi vector will be this way. Final vector is like this, north towards this side. So slide it. I think you can put it right over here. This is your final vector. Now what you can do is just join both of them. This is your change in velocity. Now you can see this is 90 degrees. This is how much? Final is 40. This was 40 and this was 30 units. So obviously delta V by Pythagoras theorem will be 30 square plus a 40 square, which is nothing but 50. But 50 in this direction, west and north, so northwest, somewhere in northwest direction. Is that making sense? Hi Nikhil. Thank you so much Ninja, thank you so much Sanya, means a lot for those hearts. It takes a lot of effort, trust me, to put that hard, and it means a lot when you type in such things. No problem, Navya. You can continue from here. Hi, Manjunatha Suguna. Is that clear, guys? Do you understand the difference between change in the scalar and change in a vector? Notice which quantity is asked. If momentum, vector, so use vector subtraction. Change in, let's say, I don't know, volume. Volume is a scalar, so just subtract the values. Change in mass, scalar, just subtract the values. Change in force, yes, it's a vector, so use vector subtraction method. All right. I'm very good now. I hope you two are doing great, and yeah, and all excited for this session. You have forgotten, yes, Jagdish, I have forgotten 2022 aspirants, because you are supposed to study for chemistry exam. You are not supposed to study for physics. Obviously, I will not be taking classes for 2022 till your chemistry is over. So stop blaming me, Jagdish, and study for chemistry. Two equal vectors have a resultant equal to either of them. Then the angle between them will be two equal vectors. Come on, guys. Have a resultant of equal to either of them. Then the angle between them will be. Come on. Yes. So HBD, happy birthday to you, I guess. Or happy birthday. So all you need to do is not use calculator, know the tables, know the constants, know some manipulations. You should be very good with manipulations, and whenever you have to add, multiply, you should know, okay, this is the closest number, this is the closest digits to this, so maybe I can do some approximations. So good with approximations, good with tables, good with constants, not using calculator, and do a lot of manipulations and substitutions. You will get very good with it, don't worry. The first chapter of physics depends. For 11th it's obviously units and dimensions, basic maths and all of that, but for 12th it is electrostatics. Okay, so some of you have started answering. Is it option A, guys? All right, let's figure it out. Two equal vectors have a resultant equal to either of them. That means A vector plus B vector is equal to C vector. The magnitude of C is magnitude of B, which is also magnitude of A. Now this can only happen in one case. If you think of triangle law, this can only happen when all sides are equal. And when will all sides be equal? This is when all sides will be equal. Like this, this is A, this is B, and this is your C vector. And the question is, find the angle between the two of the vectors. A lot of people are going to mark this and they are going to say, yes, it's going to be 60. That's not the correct answer. Be careful. These two vectors, heads and tails, are merging. You do not measure the angles like that. You measure angles only when their tails meet. So slide this vector here, and then you will realize this is the actual angle, or basically take this vector here, then you will realize this is the angle, and that angle is actually 120 degrees. So this is correct, this is wrong. So hence the angle is option A, which is 120 degrees. Got it, my warriors? So be careful with such things. Moving on to the next one. If the sum of two unit vectors is 1, then what is the difference between them? Very interesting question. Very good, Jagdish. If your boards are over, bacha, there are other students also, bacha. Okay, most of the students, 80% to 70% of the students are writing CBSE. So we have to wait for them. But meanwhile, you know, Jagdish, what is available? My Zero to Hero series is available. My Pathfinder series is available. My mock tests are available. Have you watched all of them? Have you completed all the concepts? If the answer is no, then you know what to do. Have you checked out all the lectures in the crash course or in the pro course? Have you started solving all the assignments, bacha? Have you completed the mock test, bacha? Have you started solving the PYQs, bacha? Have you started solving Tattva modules and their assignments? Have you completed them? If not, then please do it. Okay, I'm here only, and I'm going to take your revisions immediately after the physics exam. Don't worry, I'm not going anywhere. Okay. And all the best, Talapati Giri. I'm so glad you came here to seek the blessings. Okay. So, okay, my school will be telling JEE chapters in 8th, 9th, 10th. That's too early, Mr. M. Enjoy your life and just lay your foundation and develop skills. You don't have to study so much in 8th, 9th, 10th. Okay. Yep. All right. Yes, Ninja. It's a big list. Obviously, if you want to get good marks, obviously you need to do all these things, na? Yeah. Right. The sum of two unit vectors is 1, then what is the difference between them? It's very simple. I'll tell you what you should do. See, two unit vectors, that means A cap and let's say B cap, is 1. That means the resultant is also a unit vector. Interesting. A cap and B cap's resultant is also unit vector. All are of the same magnitude. So that means it will look something like this. This will be A cap. This will be A cap. This will be your B cap. And this will be your resultant. All of them are unit vectors. Obviously, it will be an equilateral triangle. All sides are equal, 60, 60, 60 in between. Now the difference between them, so you take the negative of any one vector, let's say B vectors. So negative will be like this. This will be minus B hat. Now the question is, what is A vector minus B vector? Meaning this one over here. This is A hat minus B hat. What is the value of this? What is the difference between the two when subtracted? Very simple. Remember the subtraction formula? The subtraction formula was A square plus B square minus 2AB cos theta. Alright. Here in this case, both A and B both are unit vectors, so it will be 1 and 1. Minus 2 into 1 into 1. The only catch is what is theta over here. Let's see how many of you can tell me what is the value of theta. I'll be very happy with that. MACD Agra, V enthuse has grown bigger and we are now calling it V Enlite because now we are taking care of all the kinds of competitive exam, be it JEE and NEET. So we are a bigger and a stronger family. So enthuse is still there at its roots. At ground level, we are still enthused, but we are just calling ourselves V Enlite because now we are taking care of JEE and NEET. Thank you HBD so much. Which is the best intermediate of Polytechnic? Mr. M, can you leave a comment after the session, bacha? I will definitely help you out. Oh, see, everybody made a mistake. Everybody made a mistake. I knew this. Many of you are going to say 60 degrees. That is wrong. It is not 60. Look at the angle between A and B. It is 120. This is the correct angle. The previous problem, I just told you, always slide this vector. The angle between A vector and B vector is 120. So theta is always the angle between A and B, not A and minus B. This is the most common mistake. What is the most common mistake? Many students, while using the formula, they get confused. Is theta the angle between A and B or A and minus B? Theta is always the angle between A vector and B vector. You are subtracting it. That minus B happens automatically. So this will be 120 degrees. Now you know cos 120 is nothing but minus 1. So this will be 1 plus 1 minus 2 into minus half. So it will be nothing but 1 plus 1 plus 1, which is nothing but root 3. Hence the correct answer should be root 3, which is option C, guys. Bingo! Amazing, Aditya. No problem, Pranal Pujari. I'm so glad at least you are come here. There is a lot of stuff which I'm going to do today, guys. Lot of stuff. Okay? I'm so happy, Navya. I'm so happy. You're coming from the land of God's Lord, the land of beauty, the land of, you know, all the amazing backwaters and all the amazing landscapes. And I'm so glad that you're enjoying the classes just meant for all the students out there who want to learn in English. Okay, moving on to the next question. All right. So, yes, I think we are. Oh, I think this is just a blank slide. Okay, so we have to go to dot product. Okay, let's go to that. Maybe I can just give you one more question for the fun sake. Just fun sake. Okay, let's just do one more question. Let's see if you guys can do this or not. Okay, just let's see if you can do this. Imagine there are charges. Imagine there are charges. Okay, something like this. Imagine. And I tell you they are on the vertices of some square or something. And the positive obviously repel by a force of F. The positive repel by a force of F. Okay. Then I tell you the positive and the negative attract by a force. Maybe the charges are different, distances are different. So I don't know, maybe the negative charge is huge. Maybe it's very negative. Maybe a force of 2F. Example. There's no harm in assuming. Okay. Now the question is, what is the net force on this charge? Find the net force on this charge. That's the question. Let's try to do this. Sir, I'm not getting semiconductor notes on Telegram. I think it would have gone way up bacha, or maybe it was there on the previous Telegram group, most likely, okay. So let's solve this question. Very easy. Positive, 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 repel. So this positive will create a repulsive force here, F. This positive will create a repulsive force here, F. Got it, my warriors? All right. Now this positive and negative will attract. So there will be an attractive force like this, and that is given by 2F as per the question. Now when you want to solve such a problem, you can do it together, or you can split it into components, or take it one pair at a time. HBD, this is for NEET also. And I'm teaching the long-term batch, but not for NEET, for JEE. But I'll tell you one thing, you have the NEET HOD who is teaching you physics. So trust me on this, you will not have any problem. If you have problem, I will only come and teach you. But I'm so sure that you will be like, sir, the sir is so good, I'm having fun. Trust me on that. Oh, root 3F. Okay, so let's try to figure this out. First, take care of these two F's. First, take care of these two F's. F and F, but in perpendicular direction, will give me a vector here. And what will be the value? It will be F square plus F square, which is nothing but root 2F. Root 2 times of F. Everybody agrees through Pythagoras. Now, you don't have to worry about this F and this F. It's already been taken care of. So you have a root 2 times F vector here, and another vector which is 2F over here. So two vectors have to be added. So this was our first step. This was our first step. Now this is our second step, guys. This is our second step. 2F here, root 2F here. Opposite vector, subtract, right? They will cancel, but not completely because their magnitudes are not same. So what will be remaining? What will be remaining? Which color do I use? Yellow. Okay. So 2F is bigger, root 2F is smaller. So there will be only this much remaining, and it will be 2F minus root 2F, which is nothing but F common, 2 minus root 2. Hence, that is your final answer. So this is your final answer. Third step. 3 steps you got the answer. Everybody got it? So root 3F, no. 2 root 2F, no. 2F is there, root 2F is your opposite, so minus. Got it, guys? Everybody with me? Understood? So that is why vector addition, subtraction, these concepts are very important for you guys when you are solving problems of electrostatics and magnetism. Keep this in mind. Okay. So, oh my God, Ninja, I'm so happy, and I'm pretty sure you are going to have a ball. You are going to have an amazing, fabulous time out there. Very good. Very good. F2 minus root 2. Correct, Juhi. Yes. Very good. Bacha log. Now, you can also have some questions on 3D, and this is going to happen a lot. This is going to happen a lot, and many students face problem in this. Okay. Just imagine, okay. You have a ring. Just imagine you have a ring. Many students fail to understand this. Let's see if you guys can understand this problem. You have something on the x-axis, let's say a charge. Let's say a charge. Okay, you have a positive charge. And this ring obviously is also positive charged. Example. This ring is in the YZ plane. I want you to visualize it. This ring is in the YZ plane. This is the axis of the ring, and on the axis, so if you think of a ring, on its axis there is a charge, and I ask you, what is the direction of the net force? Where is the net force on this point charge? Let's see if you can visualize and let me know. Yes, now we are 2 minus root 2. So many students face difficulty in this. I want you to develop that understanding of vector addition and subtraction. It has nothing got to do with electrostatics, apart from the fact that you should know what is the electrostatic force of attraction or repulsion formula, which is the Coulomb's law. Let's keep Coulomb's law aside. Let's focus on the vector addition part. That's all, because I want you to develop that understanding, 3D concepts, visualization. Every positive charge will repel this positive charge like this. So there will be a repulsion. Even this positive charge will create a repulsion here. This positive charge will create a repulsion here. This positive charge will also create a repulsion here. Now believe me, although I am showing all these repulsive forces in the plane of the board, they are not coplanar. No, it is not zero. It is not zero. They are not coplanar. How many of you got this? That it is not coplanar. I'll tell you why. Just visualize this, guys. Imagine a ring over here and a point here. This point applies a force here. This point applies a force here. This point applies a force sideways. This point applies a force sideways. This point applies a force diagonally down. This point applies a force diagonally up. This point applies a force diagonally up there. This point applies a force this way. So if you notice, Arvinder, just check, refresh, my voice should be there. If you notice, all the forces are in the form of a cone. How many of you realized that it is actually in the form of a cone? So it's a little bit tricky for me to draw, but I will try and draw this by drawing the cone first. It's easier that way. So just imagine this is the cone. All right, this is the axis, of course, and all these forces are like this. See, visualize that. They are all on, I can just show it dotted line because these are behind, like this. They are all in the form of a cone. Now, do you realize these forces, you can take it in pairs. Take pairs. One force here, one force here. Take pairs diametrically opposite. These are pairs which are diametrically opposite. So these are the pairs of forces. Each force will have two components. One component here, one component here. This force also, one component here and one component here. This is along the axis. This is perpendicular to the axis. You guys only tell me which components will add. Which components will add? Think carefully. These are two forces. Each force has two components. This one, two components. The one down, two components. Out of all these blue forces, which are the components, which components will add? Which components will subtract? Think about it. Which components will add? Which components will subtract? Will the perpendicular add? Will the axial along the axis add? Think about it. Guys, visualize this. That is why I am teaching you this chapter, so that your 12th will become easy, peasy, lemon squeezy. X-axis will add. Why? This will cancel opposite. Na? This is like this, this is like this. One undo is pushing here, another undo is pushing here. Their forces will cancel. Any vector will cancel. So this will basically cancel. This will basically add. Correct? Now, how many pairs will be there? So many pairs. Pairs, 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 couple, couple, couple. I am a single. So sad the life is. Couples everywhere. It's like a lover's spark, isn't it? Couple, not a couple force, but pairs. You can take pairs. A pair here, pair here, pair here. Each pair will have two components. Axis, perpendicular. Axis, perpendicular. But all the perpendicular components cancel. All the ones along the axis add. So many axial components. So many axial components along the axis, 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 along the axis. How many ever pairs are there? All those components will add, and that will give you the net force. And that will give you the net force. Understood, guys? Is that clear? So this is how you have to develop the visualization. This is how you have to create the understanding. Formula, I am not worried, that you will do. I have already taught, it is there in the playlist. Problem is understanding which component will cancel, understanding which component will add. That's all. Great. Let's go ahead to the next concepts, and that is all about the dot and the cross product. Perfecto, guys. I'm so glad, Angel. What if an opposite part is cut? What if an opposite part is cut? Then that part will be missing. Then you will have some residual components. Then the force will not be along the axis. You will have some residual component. But that thing and all is not there in JEE. Don't worry, guys. Hello, Aishwarya Menon. Alright. So, dot product, generally used for which all things? For power, for work, for flux, and so much more. You will learn flux in 12th standard, don't worry. Like, sir, what have you written? I don't know, I have not yet started 12, don't scare me. Don't worry, I'm not scaring you. It's all based on dot product. You don't have to worry what is flux. Just remember, power, force dot velocity, work, force dot displacement, flux, electric field dot area. Now the moment you see this, I'll be like, what nonsense, sir, you have written area, are you sure? Are you blind or have you gone mad? No. Area is also a vector in physics. And what happens is, whenever you take any shape like this, let's say this is that plane, this is your area, this is your surface, anything hypothetical, a perpendicular drawn to that surface, yes, is nothing but the area vector. Why do we treat area as a vector? Many of you might be wondering, sir, why did you treat area as a vector? Because it helps us in calculation and dealing with so many other quantities like flux. Yes, it helps us in many quantities, and I'll give you certain examples like this. Observe. I know you guys are scared now. See, look at this. Maybe, all right, something like this. Okay, this is a surface. Okay, this is a surface. I'm just shading it. And it's inclined, it's like, I don't know, I should take a book or something maybe. All right, where is my book? Okay, it's like a surface. My God, what kind of books I have? I need to really change my books. I love my dog. I don't even have a dog. I don't know when I bought this, guys. Anyways, don't judge a book by its cover, okay? And this is a true example of that. All right, so this is area, and the area vector is like this, okay? The area vector is like this. I can split the area into two components, believe me. One component like this. It's like this behind. I don't know whether you can visualize it. And behind. And one component at its base. Like that. So if you see it from the side view, it looks something like this. This, and this. The actual area vector is this one. This is your area vector. Remember, area is always perpendicular to the surface. Okay, and then you have this area vector. This is along the x-axis, and this vector along the y-axis. So this vector is actually this vector plus this vector. So it helps us split the areas into components and helps us simplify the problem many times. Got it? So you can split the area also, like a house. Who was that? Thalapathy Vijay. Thalapathy Vijay was there in the latest movie. What is the name? Yeah, Thalapathy. What was your latest movie name? Please do the promotion also. Okay, so by the way, the dot product is A dot B. So when I say dot product, this means the outcome will always be scalar. It will be magnitude of 1, magnitude of 2 into cos of this. You can also rearrange. Beast, where is Beast? Yeah, who was that? Natarajan? Oh, yeah, Natarajan, very good. Oh no, who was the first one? Pranal Pujari was the first one to write. Oh no, not even Pranal, it was Thalapathy only. Okay, great. So this formula is also used to find the angle between two vectors, guys. A dot B upon AB. You can find the angle between two vectors. This is a very important concept. Two vectors given, find the angle. Use this formula. So you'll be like, sir, isn't A going to cancel, B going to cancel? No, it does not cancel. This is dot product. And when you have dot product, you find it like this. A dot B is AX BX plus AY BY plus AZ BZ. This is the formula for that. And A and B, these are the magnitudes. Please remember, these are the magnitudes. They're completely different things. All right. Now, having said that, there is also a very important thing which you should know. If A perpendicular to B, then A vector dot B vector is 0. This is your perpendicularity test. If two vectors are perpendicular or not, if you want to check it, always take the dot product and see if it comes out to be 0. If it is 0, no doubt, you can just close your eyes and say this is going to be perpendicular. That's how it is. R.K. Gupta, no, bacha. But maybe as a separate lecture, I will teach solid angle, R.K. Gupta. Got it? Excellent. So you should know these things, and obviously other things are very obvious, like, you know, I dot j, which is equal to j dot k, which is equal to I dot k. All these things will be 0, but I dot I, which is equal to j dot j, which is equal to k dot k, this is all equal to 1. Okay, great. Start crash course 0 to superhero Aishwarya Menon. I have already started. I have completed the term 2 syllabus. It's there in the playlist. Please watch it. I'll be starting with the term 1, 11th standard, all that syllabus after 20th of May. Just hold on for that time. Yep. Okay. Shall we go ahead? Cross product. Yep. So whenever you see cross product, you will always associate it with things like torque, angular momentum. You will also notice force on a moving charge later on. Force on moving charges in 12th standard, and basically torque is R cross F, angular momentum is M into R cross V, force on a moving charge is charge into velocity cross magnetic field. Every place you will see cross product is there, and so many other places. Force on a current carrying wire is IL cross B and all of that. So force on wire which carries current is I length of the wire cross magnetic field. So many places you are going to see this, and whenever you see cross product, remember it is nothing but A cross B, which is C. This C vector is perpendicular to A as well as B. The magnitude of this C is A into B into sine of the angle theta between them, is the angle between A vector and B vector. Keep this in mind. Now many students get confused. Sir, I don't know how to do this. I cross J, J cross K, this cross this. I always get it wrong. If you're one of those kids, I will suggest you two things. Number one. Okay, if you get confused. Number one. Remember this circle of life. What is it? I, J, K. If you go clockwise, just like the clock goes, it is positive. If you go anti-clockwise, then it is negative. I cross J, K, J cross K, I, K cross I, J. So if things like this are given, the position vector is along x-axis, the force vector is along y-axis. Position vector is along y-axis or x-axis, force vector is along the z-axis. So I, R cross F means I cross K. I cross K, you are going anti-clockwise, so I cross J, K will be minus J. That's all. Aishwarya, I have started the crash course on the platform already. It's there. The link is there in the description box. Already I am teaching there. It's going to continue even during the boards. And on the channel, I have already completed term 2. So only the remaining parts I'll be doing crash course 0 to superhero after 20th May. But my last year's crash course is still available. It's called 0 to hero series. So you can watch my last year's crash course. Okay, so this is one way. The second way is PT exercise. I'm going to be your PT master. Today I usually teach physics, but today I'm also going to teach you PT. So raise your hand, right hand guys. Anytime you see any vector cross any vector, start taking your 4 fingers in the direction of the first vector and then move it to the second vector. For example, I cross K. I is usually here, right? This is X, this is Y, this is Z. Z comes out of the plane of the board. I, which is there. K, which is towards you. Towards right and then towards you. I cross K. Are you going to rotate like this? No, you will look like a fool, complete idiot. I is there, K is towards you. Do not do this. Sir, I cross K is J, sir, because it is going up. I'll give you one tight slap. Don't do that. I cross K should not be done the big way. Don't go long way. I is there, K is here. Go the short way. I cross K. Take your right hand, put your fingers there, just curl it like this. You can see it goes from x-axis to z-axis. Your thumb goes down, it's minus j, minus y-axis. Everybody clear about this? Everybody understanding this? Is it clear? Yes or no? Understood? Oh, clear? Oh? Can we move ahead? Oh? Okay, keep this in mind. Clear? Alright. So let's solve some questions coming up on your screen. If a dot b is equal to root 3 times a cross b, then what is the angle between them? Very good, Pranal, Vishal. Amazing. Go. A dot b is equal to root 3 times a cross b's magnitude. What is the angle between them? Now, a dot b means a b cos theta. A cross b means a b sin theta, magnitude wise. And this is root 3 times of that. AB got cancelled. So cos theta is root 3 times of sin theta. So sin theta by cos theta is 1 by root 3. This is tan theta. So tan theta is 1 by root 3. Naturally, theta is 30 degrees. Perfecto. Thank you, Aishwarya. Yes, is it 30? Yeah, very good. Amazing. Go, guys. Let's move ahead to the next question coming up on your screen. And what is it? A vector A has a magnitude of 5 units and it lies in the xy plane and it points in the direction 120 degrees from the direction of increasing x. Wow. Vector B has a magnitude of 9 units and points in the z-axis. The magnitude of the cross product is interesting. Let's try to do this question. A vector has a magnitude of 5, lies in the xy plane, points in the direction of 120 degrees in the direction of increasing x. Okay, xy plane is this board's plane. So the vector A should be shown in that xy plane and it makes how much angle? 120 degrees with the increasing x. So 120 degrees is a big angle, obtuse angle. So I think I should just show it here. So this is vector A and this angle is 120 degrees. Perfect. What is the second vector? The second vector has a magnitude of 9 units. So this vector has a magnitude of how many units? 5 units. Okay. The second vector has a magnitude of 9 is along the z-axis. Okay. This is second vector has a magnitude of 9 units. Now the question is, what is A cross B? Now I know many of you are going to make mistakes, very stupid ones, but let's see how many of you can do this. Okay. Ninja, really? Should I do it like that? What do you guys say? Do you want a second lecture? Should we just do vectors today and maybe derivatives and integration in a separate class? Was it too much? Yeah. Do you want me to? I can do that, guys. No problems. I don't have any issues. Yes, all right. Okay, so then we'll do some few more questions and then we'll call it off a day. I'll change the thumbnail and change the title as well. Don't worry, guys. I will definitely do it. Okay, so that I can probably give you another big, nice class on derivatives and integration as well. Okay, so how do you do this, guys? Think. First of all, visualize. If you don't visualize, you'll make a mistake. Many of you are going to say, A into B into sine 120, that is completely wrong. That is not correct. Realize what is the angle between this vector and this vector. For that, I want you to think about the minus x-axis. This is the minus x-axis. This vector is not in the board's plane, the z, this one, B vector. It's coming out of the plane. So, if I talk about A vector, it's in the plane of the board, it's here. This vector is towards you. This vector is towards you. Definitely AKM facts. That's why you have joined the crash course and that's why we are teaching you over there with all the assignments and test series. Now tell me what is the angle between the two vectors. Come on, guys. Tell me what is the angle between the two vectors. What is it? What is it? Is it 120? Is it something else? This vector is here. This vector is towards you. Observe, look at it in a different plane, then you will realize what is the actual angle. What is the angle? It is 90 degrees. This is the angle. observe this. This is the angle is 90 degrees. Hence, when you solve the question and say A cross B's magnitude, it will be A into B into sine 90. Sine 90 is 1, so it is 5 into 9 into 1, which is 45. That's it, done, done. Good score, Thalapathy Vijay, 200 plus. Anything less than 200, you're risking your options. Okay, let's do the next question. We are just going to complete vectors today. I will do revision of basic maths, that's the derivatives and integration part later on. What is the value of P cross Q if P is this much and Q is this much? So whenever you see questions like this, which are this cross this, do not sit and expand and actually multiply. There is a very simple trick. What is the trick? Just write down the three coefficients. First one is 3, the second one is 1, the next one is 2. This is for P. The next Q has coefficients like 2, -2 and 4. And then all you have to do is put brackets, put I cap, put brackets, put J cap, put brackets, put K cap. But here you put plus, then put minus, and then put plus. This is the trick. Don't ask why, sir. I'm telling you, this is what you should do. Plus, minus, plus. This is like determinants anyways. Now, when you score very bad marks, what does the teacher do? They give you wrong. How does the teacher give you wrong? The teacher is happy, topper, front bencher is scoring correct, tuck, 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 tuck. Very rarely you get to see that, but teacher is very angry with you. Wrong, wrong, wrong. Like this, right? So, they go like this and like this. So this is the way teacher gives you wrong. So keep this in mind. Now, look at this. I cap means forget this one. This is actually I, this is J, this is K. I cap components, J cap components, K cap components. Forget this column, forget this row. Just go the way teacher gives you wrong. Like this. 1 into 4, 2 into -2. Like this. Look at that. This is what I am doing. Correct? So what will it be, guys? Just go like this, and like this. Do you see that? What I have done? Everybody understood what I have done? Go like this. So this will be 1 into 4, 4, 2 into 2, -2, -4, but put a minus sign. That's it. So this into this minus this into this. That's it. Now for J cap, forget this. Again go like that. 3 into 4, 12. 2 into 2, 4 minus. Last one, forget this. 3 into -2, -6. 1 into 2, 2. So minus that. Now it's very simple. This will be nothing but 8 I cap minus 8 J cap minus 8 K cap. Now this is the total vector, but you don't want that, you want the magnitude. So the magnitude of this will be this is square plus this is square plus this is square, which is 8√3. Done, done, done. Yes, this is for JEE 2023. If you are 11th to 12th moving students going to write JEE or NEET 2023 exam, this is for you. So HBD, I'll tell you what. Whenever you have two vectors whose cross product has to be taken, steps are there. One way was you actually sit and expand. One way was you actually do this 3i plus j plus whatever 2k, okay, cross this thing 2i minus 2j plus 4k. You can sit and expand this cross this cross this. Then you use my circle of life rule. Where is it gone? This one, I cross j is k, j cross k. Very lengthy procedure. Instead, I told you there is a very simple way. What is that simple way? Write down I is first, j is next, k is next. Write down I cap, then minus j cap and plus k cap. What is going to come in the bracket? Use this logic of how teacher gives you wrong. When you want I cap, forget this column. Whatever these two columns are there, just go like that. This into this minus this into this. 1 4s are 4, 2 into -2, -4. So subtract the 2. When you want j cap's coefficient, forget this. 3 4s are 12. 2 2s are 4. So 12 minus 4. Always put this minus this. Last one. Forget this. 3 into minus 2, minus 6. 1 into 2, 2. Subtract them. That's it. I hope this is clear. And now solve it. But the last part was finding the magnitude. What is the value? Magnitude. So hence I have taken the modulus, means x square plus y square plus z square's root. Okay? Understood? Got it? This is actually finding the value of a determinant, which probably you would have learned or will learn in maths. So I'm not sure of that. So that's why I told you without the knowledge of determinants. Okay. So irrespective of the knowledge of determinants, now you should be able to do this. Okay. Now moving on to the next one. The magnitude of the scalar product of the vectors, this and this is. When it's scalar product, then it is very simple. When it is scalar product, it is very simple. V1 dot V2 is, remember, I goes with I, j goes with j, k goes with k. I dot j, 0, j dot k, 0, k dot I, 0. So for I, oh my god, there is nothing to multiply. There is nothing to multiply, so 0. There is nothing to multiply for j also. What is it going to multiply with? Nothing. So 0. K into k, 1, but 5 into 4. That's it. 5 into 4. There is no ijk because scalar product, dot product, it's a value. There will be no ijk. So it will be just 20. That's it. Done, done. So whenever you have ijk components and you have to take the scalar product, just all you need to do is I component with I, j with j, k with k. If one of them is missing, good. It just becomes 0. Got it? And if somebody asks you, what is the angle between V1 and V2? Then what will you do? Angle between V1 and V2. Remember the formula? I just gave it to you guys just some time back. Where is it? Right over here. Where is it? Yep. Cos theta is A dot B upon AB. Cos theta is A dot B upon AB. So let's try to do this, guys, and see what do we get. A dot B. So it is basically V1 bar dot V2 bar upon magnitude of V1 into magnitude of V2. V1 dot V2, I just got it to be 20. What is magnitude of V1? What is magnitude of V1? Come on, guys. What is magnitude of V1? It will be this square plus this square. So 2 square plus 5 square, which is 4 plus 25, which is root 29. What is magnitude of V2? It is nothing but 3 square plus 4 square, which is root of 25, which is just 5. So just put it over here. So it will be root 29 multiplied by 5. 5 goes with 24 times. Hence, I will get this as 4 by root 29 is cos theta. So theta will be cos inverse of 4 by root 29. That's the answer. That's what you need to do. Got it? So whenever our question says find the angle, first take the dot product, find the magnitude separately, and then just use cos of the angle between the two vectors is A dot B upon AB. That's all. Done, done. Very good, guys. All right. So we are going to learn derivatives and all those things later on, guys. Okay. Today I don't want to keep the lecture very much loaded. And remember, guys, in the playlist right over here, you're going to see all the important lectures. So if you have missed any of your 11th standard class, please watch the nurture playlist. Physics, JEE, mains, advanced, NEET, everyone, you can watch it. This is for 11th standard. And for 12th standard students, I have the playlist right over here. So you can start watching the electrostatics part if you have not yet done it. And make sure that you attend all the classes regularly over here. I'm going to do some backlog covering series, and then I'll be doing problem solving for all the chapters. No point repeating the same thing again. I'm pretty sure you agree with this. In fact, I will do more conceptual problem solving, important, all the tricky things, how to solve the questions. That is what I'm going to focus on, and revisions and one shots, of course. So that's one of the things. And remember, if you want to be a part of my batch, then there are multiple ways of doing that. If you are in 11th and moving to 12th or in 12th right now, if you click on this link, which is there in the description box below, you will see JEE mains advanced course. Similarly, you'll also see the NEET Pro course right over here. Now in this batch, what you're going to see, all the best teachers, all the awesome teachers, all the teachers who you're familiar with. Even if you do not know, trust me, they are good. And the batch starts 9th May. That's just few days from now. Even if you're watching it recorded, trust me, there will be some batch at that point of time available just for you. And it's all the subjects covered. For NEET, it is physics, chemistry, and biology. Top teachers, live dot solving by the class teacher, so 2-teacher model, and live quizzes and leaderboards, test series with solutions, assignments, the Tattva material, all of this for 8,100 rupees. You just click buy course and you will see my coupon code would have been applied and you would have saved 900 bucks right over there. So 8,100, you get the 12th standard complete course along with the revision of 11th standard. So what happens is after the course is complete by, let's say, October, November, December, whenever, then the 11th standard revision and 12th standard revision starts. Mock tests will start, test series will start for both mains, advanced, NEET, whatever. There will be preparation for all of you for all kinds of examinations. So you don't have to worry for joining multiple classes. Even if you join a single subject tuition for CBSE, that teacher will charge you 3,000 to 4,000 per month per subject. This is 8,100 for one complete year till your last exam, NEET, advanced, whatever. All the subjects, test series, assignments, material, recorded class, live doubt solving, everything included. So it's definitely worth it. If I was a student, I will definitely take it. I'm not saying just because I'm in Vedantu. Okay, I have no gain in this. Let me tell you that. So this is something which I really want you to get yourself enrolled into. Alright, I hope you guys had a great time today, and I'll see you guys in the next class. Tomorrow there is going to be a match, and our day after tomorrow I'll definitely have another session for the backlog covering series. Thank you very much for joining in today. Had a great time, I hope, and please stay well and share the video and keep yourself active, motivated. Please come to my sessions, and I want you to see all these classes live. If by chance you're not able to see it, then it's okay. Please watch the recorded session as well. Share it with your friends. Please spread the word that Shreyas sir is here for you. And I'm going to be with you till JEE 2023 or NEET 2023. Whatever exam, this is the channel just for you guys. Anything you want to ask, let me know in the comments, or you can ping me on my Instagram. You can tag me out there. I really like interacting with all of you. Will I teach a revision after 12th is over? Yes, Ninja, definitely. Thank you, Natarajan. Please teach GOR NEET also. GOR NEET also. GOR means happy birthday. I'm not sure what you mean by that. But I'm teaching. All my micro courses are available for NEET students as well. Thank you, Navya. Thank you so much, guys. Have a great time. Please have a great dinner. I am also very hungry. And I'm so sorry I was not able to do derivatives and integration. But you guys are also tired. I'm going to do derivatives and NEET. The integration, a big lecture again in tomorrow or day after tomorrow. Okay, so stay tuned. Bye bye. Take care. Hasta la vista. Signing off.